All right, today we're going to be graphing polar function graphs. So last time we graphed polar coordinates. Today we're going to do polar function graphs. And so we're going to start that with a quick explore, have you guys go through the calculator and look at some of these to see what is going on with these graphs. So to do that, we're going to set up our calculator to see a polar one. So we go to mode. Remember in AP Pre-Cal, we always want to be in radian mode. So that's the first thing we want to look at. Make sure you're in that radian mode for AP Pre-Cal. Then if you come down, instead of being at function, I'm going to move this over and go to polar. That changes my graphs from the rectangular coordinate plane to the polar coordinate plane. The next step I'm going to take here is to adjust my window. We just want to get the best view we can see for these polar graphs. So for my theta minimum, I'm going to go to 0, and then my theta maximum, I'm going to go to 2 pi, which is this right here. Pi over 24 is a good default right there, which is that 0.13. You could go to 0.005. That's a good one as well if you wanted to just round off a number. Now for our x min, I'm going to go to negative 7.6. And then to our x max, I'm going to do 7.6. And then for the y's, leave that one alone. And then for our y's, we're going to go to negative 6 to 6. Okay? Now when I go to my y equals, I see it says r equals. And so you're going to go ahead and put in the graph there for cosine. And when I hit my usual X button right here, this one here, it is now going to show the theta since we are in the polar functions. So it automatically goes to that. And then we hit graph, and here is my graph. It looks rectangular because, of course, your calculator is built as a rectangular, but this is the polar graph, and so it goes 1, 2, 3, 4. So we've got a circle with a diameter of 4. So I'm going to go 1, 2, 3, 4. And there's my circle. So you're going to continue doing that. Plug in the r to sine theta, negative 3 cosine theta, negative 2 sine theta, and see if you can come up with what is happening with these graphs. All right, so I have gone ahead and graphed the other three right here. And so for the hypothesis, what we're trying to think of is what is going on with these graphs. And so we should have noticed anytime that it had a cosine, it was a horizontal circle. So it happened on that polar axis. When it was negative, it went to the left-hand side. When it was positive, it went to the right-hand side. Now for our sine of theta, it's vertical. And when it was positive, it went to the top. And when it was negative, it went to the bottom. And then our A value, I just wrote here radius, but that is the diameter. The diameter of our circle. All right, so now let's try another one. We're going to try these right down here where it has a 2 plus 2 cosine theta, 3 plus 3 sine theta. Again, we're going to go to our calculator. We're going to go to y equals, and we're going to put in our equation 2 plus 2 cosine theta and see what it does. And so that gives me this shape right here. 1, 2, 3, 4 is my furthest point here. So I'm going to go to 1, 2, 3, 4. There's my furthest point. On my picture here, can't see that. That's bad right there. It is going 1 and 2 up from the pole. So I'm going to go 1, 2. And then 1, 2 down from the pole. And then it has kind of little heart shape right there. And right now we're just sketching just to start looking at what these polar functions look like. So there is my sketch. So go ahead and put in the other ones, try and determine and see what you see as a similarity or a difference in these graphs. I'll give you a minute. All right, so I've gone ahead and sketched the other graphs here. Notice that they all look like this heart shape here, but the direction has changed. And so here we've got both of the numbers are exactly the same thing. That's what gives us this shape. And then when it is positive and cosine, it's going to the right. When it is negative and cosine, it's going to the left. Positive and sine is going up, and negative and sine is going down. All right, we're going to look at a few more here. Now, we do not have the same numbers here. So they are different numbers. In this case, the first number is bigger. This next one we're going to look at, the first number is smaller. We are going to start again by putting this into the calculator. So we go to our y equals, and I'm going to put in 4 plus 2 cosine theta and see what my graph does there. In this case, this one does not touch the pole. And so we've got 1, 2, 3, 4, 5, and 6. That gets me to the end there. So 1, 2, 3, 4, 5, 6. Towards the other side from the pole, it is 2. So 1, 2. And then we've got 1, 2, 3, 4 going up here. So 1, 2, 3, 4. And same thing as it goes down. And so we have something that looks like this. So you guys are going to continue, try some more of these, put them in there, see what's happening with those graphs, try and look at what are the numbers representing, what do the shapes look like, and so on. I'm going to go ahead and put this one here next so that we've got that one down. So that is 2 plus 3 cosine of theta. Again, this one has a smaller number first. When I hit graph in this case, we do go back through the pole again, but it's got a little loop there in the inside. And so we are at 1, 2, 3, 4, and 5 all the way to the end. Then it's got 2 going up and down. And then my loop is 1 unit. And so we get a picture that looks like this. All right, go ahead and pause it and look up, plug some more of these in there, start kind of really thinking about what those numbers are doing, what the shapes look like, and so on, and then we'll come back together. All right, so I've sketched the rest of the polar functions here so we can see what's going on with those. Notice that all of the ones that had a bigger number in the front all turned out to be pretty much the same thing, not touching the pole. It is units away from it. And then again, the cosine goes horizontal, the sine goes vertical. And we'll get more into the details as we move forward. Now, when the number was smaller, it did go back to the pole and cause this loop. Every single time that the number was smaller, it went back to the pole and had the loop inside. And again, our cosines were horizontal and our sines were vertical. Look at one more here before we go on to today's lesson. And so this one is when we have a number and then a b value. So when I put this one in here, 3 cosine of 3 theta, and I hit graph, we get a picture that looks like this. You can't see that. Sorry about that. There it is. We get a picture like this. It's called a rose. And so this one has 3 petals. It is going 1, 2, 3 on the polar axis. So we've got 1, 2, 3 on the polar axis. And then our other 2 are evenly dispersed from there. So we've got 1, 2, 3. And so there is our rose. And it's got 3 petals. Go ahead and sketch these other ones so we can talk further about what it does when there is a number in the front and a b value. Anytime we've got this b value, we are going to end up with this rose. So go ahead and sketch those, and then we'll talk about them again. All right, so I've gone ahead and sketched the rest of my rose ones here. So a couple things you should have noticed. The A value, this number on the front, is the size of the petal. So when it was a 2, this petal is 2 units long. When it's a 3, these petals are 3 units long. You also should have noticed that when the n value is even, we are doubling the number of petals. So here it was 2, so we have 4 petals. Here again, it was 2, and we've got 4 petals. When the number is odd, like 3, then we just keep that number 4 petals. So we have 3 petals on that one and 3 petals on this one. For the cosine one, it always has one on the polar axis. And for the sine, it never has one on the polar axis. All right, we are going to dig deeper through that as we move through our explain now. All right, for polar functions, the inputs are given by theta, which is the independent variable, and the outputs are given by r, which is the dependent variable. On the AP exam, you're going to see questions like this one that say the graph of the polar function r equals f of theta, where f of theta equals 3 minus 3 sine theta is shown in the polar coordinate system for 0 to 2 pi. So that's what the wording is going to look like for it. In the past, we went ahead and graphed these on the rectangular. If you remember, this was our midline at 3, and then this was our amplitude of 3. And then this is the sine curve, which starts in the middle here. It is negative, so it would go down. And so we would get a graph that looks like this. So we have graphed these before. Now we're just going to graph them on the polar function table. And so some people think that the easiest way is don't learn the rules. Just go ahead and figure out what these are and graph them. So we're going to plug in a few just for you to feel comfortable with that. For example, 0 degrees. I would plug in 0, and so I get 3 minus 3 sine of 0. We all know that unit circle really well, so sine of 0 is 0, so this would be at 3. So my 0 angle is right here on the polar axis. I would go to 3, and there is my first point. I do it again, 3 minus 3 sine of pi over 6. Again, we know that unit circle really well, so the sine of pi over 6 is 1/2. And so we get 3 minus 3 over 2, which is 1.5. And so at pi over 6 here, I would go 1.5. And there's my next point. I would continue to do that by plugging in points. And so this gives me 3 minus 3 root 2 over 2. That's not an easy one to come up with on the number, so I'll go ahead and give you that decimal. That's 0.8787. And so at pi over 4, I'm at 0.87. That's right there. I'm going to go ahead and give you some more of these because the rest of them are, some of these are not good for decimals. So this is 4.4019. Now this one's an easy one for you to do. 3 minus 3 sine of pi over 2. The sine of pi over 2 is 1 times 3, or times negative 3, would give us negative 3, so we get 3 minus 3, which is 0. So at pi over 2, which is this one right here, we are at the pole, so that gives us that point right there. Again, I'll give you a couple more points for the decimal ones, just to move us along. Pi is another easy one to get. So 3 minus 3 sine of pi. The ones on the axis are always the easiest. And so the sine of pi is 0 times that would be 0. So that is at 3. So our pi here would be 3. And so I would come out to the 3. Now you should recognize some symmetry. At this point, we see this value is here. We see that these are symmetrical on this side, and so we would have our matching ones over here. And then I'm going to keep going with those values. This is 4.5, 5.1213, 5.5981, 3 pi over 2. That's another one of the ones that are easy. That one comes out to be 6. So my 3 pi over 2, I am at 6 right here. Notice these values here are moving towards that 6. So we were at 3 here. It got a little bit bigger as it went, and then it gets to that 6. Now, as we come to this other side, we're going to see that symmetry again until we return back to 3 for a full cycle around. And so looks something like this. Should be a little bit rounder, but that you get the basic gist of what that looks like. Now on our Explorer, we saw some like this that look like that heart shape. That is called a cardioid. So you can go ahead and come up with a table of value, sketch the points to get your figure. We are going to talk about the rules just so that you know how to do that as well, but we wanted to start with how are these points coming. So first, let's talk about the circle ones. Again, we looked at these on the Explorer. So it's just to get you guys comfortable with this. When you saw cosine, we talked about it was on the horizontal. When we talk sine, it's going to be on the vertical. So we know it's going to be on one of these two right here. We discussed that this number right here is the diameter of our circle. And so 1, 2, 3, 4 would give me the diameter of this one. Since this is vertical, I would go 1, 2, 3, 4. And there's my circle. A little lumpy on this side, but it should be a circle. All right, so one of the things that we notice is that when it's positive, it opens right for the cosine, and when it's negative, it opens left. And then for the positive, it opens up, and for the negative, it opens down. So get comfortable looking at that sine and cosine, making sure you understand which direction it's going to open. And then we said this number in the front is a diameter. So when you look at this equation, you should be comfortable knowing it's a circle. You should be comfortable knowing that that's the diameter and which direction it's going to open. All right, the next one we'll talk about is the rows. And so we said the rows can come in odd or even, in cosine, or odd or even in sine. So when we look at this equation here, the number right here, 4, is the size of the petal. And so we know it is 1, 2, 3, 4 units. When our n value right here is odd, then that is the number of petals. So this would be 3 petals. When it is even, we are going to double the number of petals. And so this one's going to have the 4 petals because that part is even. This is still 4, so we're going to have a petal that's 4 units long. If it is cosine, it is always on the polar axis. So cosine, always on the polar axis. If it is sine, never on the polar axis. For the sine ones, the rules are basically the same. This right here is the size of the petal. So 1, 2, 3 is going to give me that length of the petal. If it is odd, then we are going to keep that number of petals. So this would be 5, n equals 5. If it is even, we are going to double that. And so that would become 8 petals on this one. All right, this one's not graphed here so that we can sketch a picture of it. You can find the exact end of that petal on any of these because we know it is 1, 2, 3 units out. So we know for the end point of the it is the radius. So I can plug in for this one. I know my radius is 5, so I can plug in 5 here. And then I can solve for theta, and that would give me the first one. And then we would evenly space them from there. In this case, I have 8 petals, so I know I need 4 up here and 4 down here. Again, it would never be on the polar axis, so I want none on that. And so we've got like 1 right here. I'm just sketching the picture because on the AP test, all you're going to be required to do is match a graph to the equation. And so you will never be sketching the actual picture like that. So I'm just trying to help you out here. So there we go. We've got 8 petals. They have the petal length of 5, and none are on the polar axis because it is sine. All right, so let's look at some of those questions that can help you answer AP questions. It tells us here to describe the polar function. So they've given us the equation here. They ask us, is that a line, a circle, or a rose? I have a B value, so I know it's going to be the rose. This is odd, so I'm going to keep that number of petals. So that will have 7 petals. And then this number in the front is our max distance from the pole, which is the size of that petal. So that would be 2. For our second one, we have a number and then sine of theta. This is not the rose since it does not have a number there. So this is the circle one that we talked about earlier. It is sine and positive, so it is going to open upward. And then the max distance from the pole would be 9. That's going to be our diameter of the circle. All right, for our next one, we do have a B value there. So this is a rose. This is an even number, so we're going to double that for the petals. So this is going to have 12 petals. And that max distance from the pole is going to be 8 because that's going to be the length of our petals. In some questions, you will be given the graph and then you'll have to pick the equation. So we're going to review that here by writing the equation of these 3 right here. All right, so the first one is a circle. It does open horizontally, so I know that is cosine. It is opening to the right, so I know it's positive. And it has a diameter of 2, so this is 2 cosine theta. For our next one here, it is a rose. We have 4 petals. None of them are on the polar axis, so I know this is sine. And so we get R. Our petal length is 1, 2, 3, 4. And so we're going to have a 4 there. And then sine of 2 theta. Since we have 4 of them, that's an even number, so we know that it was doubled. And so there is our 2. In this case, we have a circle and it is opening downward. Since it's vertical, I know it's sine. Since it's opening down, I know it's negative, and this one is 1, 2, 3, 4, and 5. So this would be R equals -5 sine theta. All right, the other ones that we talked about on the Explore, I call them Limancon. Most people call them Limancon because it's French, but I'm just going to go with Limancon here. This is where we had a number, plus or minus, another number, and then cosine or sine. So we had 2 numbers here. One was being added or subtracted. And so that gave us a couple of different shapes. When the 2 numbers were exactly the same, it gave us that cardioid. So the one that kind of looked like a heart, like this, and it did go through the pole right there. When our A value was bigger than the B value, so this number in the front was bigger, that's where we got that dimpled one, the one that did not touch the pole. So here was the pole, and it kind of went something like this. It did not touch that pole. When the A value was less than B, so this number is smaller than this one, then we got the Limancon with the loop, which looked like that. All right, we're going to look at these with the rectangular one there so you can see what's happening. We graphed many that were like this before. This was the midline of 3, which goes right there. This is my amplitude of 3. So 6 is my top line, 0 is my bottom. This is the cosine one. So it starts at the top and it's got a period of 2 pi. So it goes all the way here. All right, we're going to use those points to go ahead and graph our cardioid. So I see that at 0, I am at 6. So 0, I'm going to go to 6. 1, 2, 3, 4, 5, 6. Perfect. Okay, at pi over 2, I'm at 3. So at pi over 2, I'm going to go 1, 2, 3. At pi, I'm at 0, so I'm at the pole. At 3 pi over 2, I'm at 3. So 1, 2, 3. And then at 2 pi, I'm back over here at this 6. So we get a graph that looks like this. So let's talk about a couple of things. It was cosine and positive. So again, it went on to our polar graph horizontally. and to the right because it was positive. Notice that this part right here is 6, our longest portion of this, and this is 3 and 3. So our longest portion right there is the A plus B. Now this shorter part right here, 1, 2, 3, that is the A value. Or the B value, whichever one you want to call it. So A is this length right here. A plus B is this length. They're both the same number, so I know it's a cardioid. Again, if it's positive cosine, it opens to the right. If it's negative, it opens to the left. And then if we have sine, it's going to open up or down. So that's our cardioid. Let's go to our next one, the dimpled cardioid. Here is the rectangular for this particular one. So we get the dimpled cardioid when this number is bigger. So the 5 is bigger than the 3. The 5 is my midline. The 3 is my amplitude. And this is cosine, so it starts at the top and goes back. So at 0, I am at 8. So 1, 2, 3. These numbers get a little tight here. 1, 2, 3, 4, 5, 6, 7, 8. Right there. At pi over 2, I'm at the 5. So I'm going to go 1, 2, 3, 4, 5. At pi, I'm at my lowest point there, which is 2. At 3 pi over 2, I'm back at 3. Nope, sorry, at 5. And then at 2 pi, I'm back up at the 8, which would be right here. So that's going to be my dimpled one because it does not touch the pole. In this case, it never touches this pole right here. So when our number's bigger up in the front here, it is not going to touch the pole. Now let's talk about these values that are in here. From the pole to this longer side right here, it is that A plus B. We found it was 8. And so that's the 5 plus 3. That's our maximum value. This right here is our minimum value. This one right here at 2. So it would be the A minus B. And then this side is our A. Which is that midline. All right, now let's talk about some more questions that you can get on the test. It tells us here, use the graph of the polar function r equals f of theta for 0 to 2 pi to answer the following. The first one says, write the equation of the polar function. So looking at this graph, we want to determine which one is this. So these are MCQ questions. They're never going to be FRQs. They are the MCQs. And so we've given 4 equations here. The first thing I would recognize is that this is opening vertically. So I can simply cross out my cosine ones. I know it can't be those because it is opened vertically. And then this one is positive, so I know that's going to be the answer since it opens upward. I can go ahead and check by counting 1, 2, 3, 4, 5, 6. That is the total of these two being added together. Then 4, which is my first number, is how much it's going to the side and to the side. All right, the next question says if the domain of f is restricted to pi over 2 to pi. So we're talking about this part of the graph right here. Is the function positive or negative? And is the function increasing or decreasing? So this is a little bit harder to see on the polar graph. So I would encourage you to sketch a picture on the rectangular. So now that we've picked what the equation is, we see that the midline is at 4. And then our amplitude is 2. So I'm going to go 2 up from that 4 and 2 down. Just by looking at this part so far, I can already tell everything is above the x-axis, so the answer is positive because it doesn't matter which interval, it's going to be positive since it's all above the x-axis. But this is the sine graph, and so the sine graph starts in the middle and goes this way. So this is 2 pi, this is 0, and so right in the middle would be pi, In the middle of that would be pi over 2, and then this one would be our 3 pi over 2. Get comfortable using those values because those are the ones that are usually restrained by our questions here. So it's asking you for pi over 2 to pi. So we're looking at this portion of the graph right here. It is positive because it's above the x-axis. And the next question says, is it increasing or decreasing? This is decreasing. Since as we move from left to right, it is going down. All right, our last one here is the inner loop Limancon. So we've got 1 plus 3 cosine of theta. In this case, that 1 is smaller. That's when we get the loop one. We have graphed our midline at 1, and our amplitude is 3, so it goes up to 4 and down to -2. At 0, I am at 4. At pi over 2, I'm at 1. At pi, I'm at that -2, which means I'm going back in this direction. So pi is over here, but remember, if we had a positive number, it would go this way. If it's negative, it goes in the opposite direction. That's what's causing that Limancon with the loop. All right, at 3 pi over 2, I'm back at 1. And then at 2 pi, I'm back over here. And so we get our loop that looks like this. Well, the loop is kind of off there, but hopefully you get the point. All right, so let's talk about those values. So still that longest piece is going to be the a plus b. Then this portion right here is going to be that first number of a. That was 1, so we're going 1 unit up and 1 unit up there. Then this inside part for our loop, that would be our b minus a, which is 2 in this case. So we see our loop is 2 units long. So b minus a would be the size of the loop. All right, the questions that are like the test questions. So here is an example of that polar graph, and it's asking us to find the equation. So the first thing I see, it has gone to the left. If it's horizontal, it's cosine, and if it goes to the left, it's negative. So I can throw out my signs because it's horizontal, and it needs to be negative because it went to the left. Again, when it's asking about positive and negative and increasing and decreasing, graphing it in our rectangular is the easiest. So I'm going to sketch a picture of that. Our midline is 2. And then our amplitude is 5. So I'm going to go up 5 and down 5 from that one. All right, our cosine usually starts at the top, but this is negative. So it is going to reflect down to the bottom. So it's going to start here, and then it goes up and back down. Remember, they're periodic, so it'll follow from that point. 1 full cycle is 2 pi. And so this would be at pi. We would be here at pi over 2, and this one would be 3 pi over 2. In this case, we're asking for pi over 2 to pi, so we're looking for this section right here. This is above the x-axis still, so if we were asking for down here, it would be considered negative, but we're still above the x-axis right here, so this one too is positive. And as we move from left to right, this graph is going up, so this one is increasing. Early in the year, we called that increasing at a decreasing rate since it is concave down. So just throw those vocab words back at you. All right, that is graphing our polar functions. Hopefully you got used to graphing them, seeing what the shapes are, what the numbers are, so that you can answer these questions.